this is problem number 4 from section 4.5. In this problem it says find the zeros of f of x given that 1 0 is k. So they tell us that 1 0 is negative 4i here. So that tells us that if we know 1 0 is negative 4i, this is an imaginary 0. And if you remember from our conjugate zeros theorem, if we have one imaginary 0, then we actually are going to end up with 2 imaginary zeros, right? Because aka imaginary numbers come in pairs. So negative 4i, the conjugate of that is going to be the 4i. So negative 4i and 4i are zeros in this problem. So now we can write the factors. So let's go ahead and write the factors now. We know that the factors of this 4th degree polynomial so far are x minus negative 4i, which would be x plus 4i, and then x minus 4i here. Right? And you can see they're conjugates of each other. Right? One is conjugate of the other one, and that comes back to our conjugate zero theorem, that if you have one imaginary 0, you're going to have a second. So now let's take these two factors and multiply them together, and then we're going to do some division here to actually find out and break this down to find the other two zeros. So let's multiply these together. We'd get x plus 4i times x minus 4i. That's x squared minus 4ix, x times 4i, or negative 4i, plus 4ix, and then 4i times negative 4i is minus 16i squared. Now these cancel, and we're left with x squared minus 16 times I squared is negative 1. So we end up with x squared plus 16. So x squared plus 16 is a factor of this polynomial. So let's do some long division here. We're going to do x squared plus 16. And actually I should put in plus 0x here. I'm going to cross it out and say x squared plus 0x plus 16. We're going to do a division. And in there we're going to have 3x to the 4th minus x cubed plus 51x squared minus 16x plus 48. So x squared goes into 3x to the 4th. It goes in there 3x squared times. We multiply, we get 3x to the 4th. Multiply here, that's going to be, that'd be 0x cubed, so plus 0x cubed. We multiply this times the 16. 3 times 16, 30, 48, so positive 48x squared. We're going to subtract, distribute that negative sign. That's negative 3x to the 4th minus 0x cubed minus 48x squared. Let's go ahead and combine these together as 0. That's going to be negative x cubed. This will be plus 3x squared minus 16x plus 48. Now we're going to say x squared goes into negative x cubed. It goes in there negative x times. So negative x times this will be negative x cubed. Negative x times 0x, that's 0x squared. Negative x times 16 is negative 16x. So we're going to subtract those. And we're going to get, when we distribute the negative to each spot, we're going to end up with x cubed. This will give you, x cubed minus 0x squared, and then that'll be plus 16x. So then we can kind of cross that out, add those together. This gives you 0. This gives you 3x squared. This gives you 0. So I end up with 3x squared, and then I'm just going to bring the 48 down. We'll say plus 0x here, plus 48. X squared goes into 3x squared 3 times. So 3x squared when we multiply it. Right? 3 times x squared. 3 times 0x is 0x. And 3 times 16 is 48. Hey, we're getting somewhere here. We're going to subtract it. Subtract it all. When we subtract it, I would typically distribute it, but you can see that that all works out to 3x squared minus 3x squared, 0, 48 minus 48, 0. We have no remainder. So now we know that 3x squared minus x plus 3, that is a factor. So the factors that we have x squared plus 16, right? And then we also have 3x squared minus x plus 3. So we have 3x squared minus x plus 3. And then technically, right, we're trying to find all the zeros. So all this equals 0, right? It's like if we put this equal to 0 up here. Now, we already know this side of it. Like if I do x squared plus 16 equals 0, when I do the zero product property here, I'm going to end up with negative 4i and 4i. That's what they gave us that in the beginning. So I just need to look at this part right here. So I have 3x squared minus x plus 3 equals 0. I need to solve this to see if I can find the zeros that I'm missing. I think the quadratic formula is the best idea here. So let's pull back out the quadratic formula. So remember the quadratic formula is negative b plus or minus b squared, all that good stuff, right? So we've got, I found it, quadratic formula. So we've got negative b, so that's negative 1 for b. So I have negative 1 plus or minus root b squared, which is negative 1 squared, minus 4 times a, which is 3, times c, which is 3, all over 2 times 3. And remember, that's x equals. So we end up with x equal, let's plug this in the calculator. Well, this will be 1 plus and minus. This will be 1, so I end up with 1 minus 4 times 3 is 12, 1 minus 36. So I end up with, that'll be root of negative 35. And that's all over 6. So I can have, I'm going to slide up just a little bit, I'm going to end up with x equals 1 plus, I can bring an I out there and call that I root 35 over 6. And then also, or x equals 1 minus I root 35 over 6. So total, our solutions are, or our zeros for this are, negative 4i, 4i, 1 plus I root 35 over 6, and then 1 minus I root 35 over 6. And those are the solutions to the problem. Hope that makes some sense.